Here's our page for 53 and 54. So 53 is a prime number because it's not divisible by 7, 5, 3, or 2. So that means 53 is prime. So once again, we write prime underneath it, and Jack likes to write his multiples in fraction form. So that, for instance, 106 divided by 2 equals 53. And then we write the one factor pair that we have for a prime number, which is 1 times 53. Now on 54, we know it's an even number, so we write a 2. And 2 times what is 54? And that's 27. And we know that 27 has factors of 3 and 9. And 9 has factors of 3 and 3. Then we count up, how many 2's do we have? We just have 1. And how many 3's do we have? We have 3 of them. So we write 2 times 3 to the third power. And Jack was supposed to have written the horizontal list of it.
3 times 3 times 3.
All right, and then we write our factor pair list. We always start with 1. 1 times 54. Then we go to the next number. Is it divisible by 2? Yes. 2 times 27. Is it divisible by 3? Yes. 3 times. And the way we find out is we cover up one of these down here. If I want to know if it's divisible by 3, cover it up and see what the other numbers multiply to be. And that's 18. Is it divisible by 4? No, because we don't have two 2's. Is it divisible by 5? Nope, because we don't have a 5. Is it divisible by 6? Yes, because we have a 2 and a 3. So I'm going to cover both of those up, and so that's 6 times 9. Is it divisible by 7? Nope, there's not a 7 in the list. Is it divisible by 8? No, because there's not 3 2's. There's only 1. And then, is it divisible by 9? Yes, and 9's already in the list, so we know that it's also divisible by 9, 18, 27, and 54. Our next number, 55, it's easy to see that it's divisible by 5, so we go ahead and write 5 times what? 5 times 11. And since 5 is prime and 11 is prime, we're finished. So we can just write 5 times 11, and then we write the factor pairs over here, 1 times 55 and 5 times 11. Let's go to the back of the book. One of the things we need in our factor tree notebook is a way to test things. So this started off as our list of numbers. So first of all, we wrote this column of numbers right here, 1, 2, 3, 4, 5, all the way through 33. And then we decided which ones of these are prime. Well, we know 2 is prime, 3 is prime, 5 is prime, 7, 11, 13, 17, 19, 23. 27 is not prime. 29, 31, and 33.
I thought it was prime.
And then we wrote the squares of these numbers. So here's my square up here. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, all the way up. And eventually we'll do 33 squared, which I think is 1089. And then it's also helpful to know some of your cubes. 1, 8, 27, 64, 125, and later on he'll add 216, 343, and so on. Now one of the tricks about finding out what things are divisible, let's say I have a big number. If I have a number that's 271, I'm going to find where 271 is on the square list. And in here, it's going to be just below 17. So if 271 was divisible by 17, it would also be divisible by a smaller number. And if 271 is not divisible by 2, then it's not divisible by 16. If 271 is not divisible by 3, it's not divisible by 15. If it's not divisible by 7, or even 2, it's not divisible by 14. So the trick is, the only numbers you have to test are the prime numbers below where the square was. So if I have 271, the only numbers I need to test are 13, 11, 7, 5, 3, and 2. And since 5, 3, and 2 are usually easy to find, we just need to know tricks for 7 and 11 and 13. So if I have a number that's 389, I would only test the primes below 389, which would be 19, 17, 13, 11, 7, 5, 3, and 2.